Hi there, I'm Elton, and this is What Happens When the Garbage Collector Runs, the next module in IDisposable Best Practices for C# developers. In this module, we're going to get a better understanding of what the garbage collector does, what happens when the garbage collector finds an IDisposable instance, and how using IDisposable correctly means our code works efficiently without relying on the garbage collector to do our cleaning up for us. We'll also cover the best practice implementation of IDisposable, which allows you to build a class hierarchy where derived classes using different mixtures of managed and unmanaged resources all get cleaned up correctly by following a simple pattern. A garbage collector is a component of a software runtime which takes care of deallocating memory which apps are no longer using. In .NET, the garbage collector has an official definition from MSDN. The .NET Framework's garbage collector manages the allocation and release of memory for your application. Let's see what that means in practice. Whenever you create an instance of a class in your code, a portion of memory is reserved for that object. That's virtual memory, which the operating system makes available to .NET, and may be a space in physical RAM on the box, or in the swap space on the disk if the OS is moving memory around. That memory allocation for the object holds its state, the current value of any member variables, and its behavior, the methods that you can call on the object. The memory allocation is exclusively for that object, so no other object in the program, or any other .NET program, or any other program from any other framework can use that piece of memory until it's deallocated. Deallocating the memory happens in two ways. Firstly, when the program ends, all the address space that the OS reserved for it becomes free again. So when your app exits, either gracefully or because of a crash, all the memory it had reserved gets deallocated. It doesn't matter how many objects are live, or whether they are disposed or finalized, the address space that the operating system gave to the .NET runtime for this instance of your app gets reclaimed. So no matter how inefficient your app, or what state it's in, when it ends it won't hang on to any memory. The second way memory is deallocated happens while the app is running, and it's done by the garbage collector. When it collects, the garbage collector looks at every object the app has allocated memory for, and checks to see if the object is still reachable by the code. In the case of local variables, which were used in a method and are no longer accessible, they'll be flagged as dead, but any objects which are reachable, like an instance field being used in the entry point to your app, is flagged as still alive. After it's checked all the objects allocated by the app, the GC deallocates all the memory used by dead objects, so that memory becomes available again.